Budsala, everyone, and welcome. You know that feeling when you're just lost, buried under a pile of instructions, or trying to wrap your head around a super complex process? Well, today we're going to talk about a simple tool that can take all that tangled logic and turn it into a crystal clear map. Yep, we're talking about flowcharts. I mean, seriously, think about it. How do you explain something complicated with a bunch of different steps and if this, then that scenarios using just words? It's tough, right? Text can be, a bit vague, and it's so easy for someone to get completely lost. It's a classic problem. And that's where this elegant solution comes in, the flowchart. At its core, a flowchart is basically a visual language. It's all about using simple, standard shapes and arrows to map out the logic. And the cool thing is, it can make any process, I'm talking everything from making your morning coffee to a super complex computer algorithm, instantly easy to understand. Okay, so if we're going to speak this visual language, we've got to learn its alphabet first. Don't worry, it's pretty simple. There are just a few core symbols that do all the heavy lifting. Once you get these down, you'll be able to read pretty much any flowchart you come across. So first up is the oval. This guy is called the terminal symbol, and its job is super important. Every single process has to have a clear beginning and a clear end, right? So you'll see this shape right at the top that says start, and one at the very bottom that says end. Super clean, no confusion. All right, next we've got the parallelogram. This one's for any time information is either coming into the process or going out of it. You can kind of think of it as the system talking to the outside world. Like when you're asked to type in your password, that's input. Or when a game shows your final score on the screen, that's output. And here's the real workhorse of the flowchart, the simple rectangle. This is your processing step. Basically, any action, any calculation, anything that's happening, it goes in here. Stuff like add two numbers, or save the file, or update the record. If something is being done, it's going inside a rectangle. Okay, now things get really interesting with this one, the diamond. This shape is all about making a decision. This is the point in the process where you ask a question. Something like, is the age over 18? Or is the password correct? And from there, the path splits, usually into a yes/true path and a no/false path. This right here is what makes flowcharts so powerful. So let's do a quick recap of our new alphabet. We've got the oval, that's our terminal for the start and end points. The parallelogram handles all the input and output, getting data in or showing it out. The trusty rectangle is for any kind of processing or action. And of course, the powerful diamond is for making a decision, where the path branches. That's it. With just these four shapes, you're pretty much ready to build anything. But hey, just like with any language, right, knowing the letters isn't the whole story. You gotta know the grammar to actually make sense. And flowcharts have their own simple set of rules, their own grammar that makes sure everything stays super clear and easy to follow. Really, the most important rule is just clarity. That's the whole point. A good flowchart always flows in a logical way, usually from top to bottom. The labels inside the shapes should be short and make sense, and you want to keep those lines clean. You definitely want to avoid a spaghetti mess of crossed lines. If you have to, you can use these little connector symbols. The goal is simple. Make something that anyone can look at and just get it instantly. And on the flip side, here are a few common mistakes you'll want to avoid. Putting something like do stuff inside a process box, that's not helpful. Be specific. Or having a decision diamond without labeling the paths yes or no, that just breaks the logic. Using the wrong shape for the wrong job, or picking colors that make the text impossible to read, all these things just create confusion and totally defeat the purpose of making the flowchart in the first place. All right, that's enough theory. Let's see how this all actually works in action. We'll look at how these symbols and rules come together to solve a real problem. We'll start with something super simple, and then we'll ramp it up a little. So for our first example, let's take a really basic task. Imagine we need a process that asks a user for two numbers, adds them together, and then just displays the total. Super straightforward, a straight line from start to finish. No decisions needed at all. And here you go. See how it flows? It kicks off with that start oval. Then we hit a parallelogram to enter two numbers. That's our input. After that, we get to the rectangle, the processing step, where we calculate the total. Then it's another parallelogram to display the result. That's our output. And we finish it all off with the end oval. See? Clean, simple, and makes perfect sense. Okay, ready to step it up a notch? Now we're going to need to make a decision. Let's say our task is to take a person's age and figure out if they're eligible to vote. And for this example, we'll say the magic number is 18 or older. And this is a perfect example of that diamond shape in action. We start, we get the person's age as input, and then, boom, we hit the decision. Is age 18 or older? And you can see the two paths branching out. If the answer is true, the flow goes down one path to an output that says eligible to vote. If it's false, it goes down the other path to not eligible to vote. And see how both paths eventually come back together to the same endpoint? That's what I mean by logical branching made visual. It's so clear. So up to this point, we've been looking at flowcharts as just a great tool for thinking clearly. But here's the really cool part, the bigger picture. They're not just diagrams. This incredibly precise step-by-step logic, it's not just like a computer program, it is the blueprint for one. In fact, the logic is so pure that some software can actually take a flowchart, just like the ones we've been looking at, and automatically spit out working computer code. It's amazing. There are tools like Flowgorithm that help students learn programming visually without typing a single line of code. And it's not just for schools. Industrial systems like Dracon, which was actually used in the Soviet space program, prove this works for really complex stuff too. People can build entire applications just by arranging these blocks. So they're not just pictures, they're literal blueprints for action. So, as we wrap this up, I want to leave you with a little something to think about. What's a process in your own life? It could be something at work, a personal project, even just a daily routine you have. How could drawing it out as a simple flowchart make it clearer for you, maybe more efficient, or just way easier to explain to somebody else? Give it a thought. Vinaka for watching.